Hi everyone. So for today's session, we'll be working on the practice assignment for week 4. Okay.
Good evening, ma'am.
Yeah. Good evening. And if at some point you're not able to hear or if I'm not audible, let me know. Okay. 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 Then we can get started with the practice assignment for week 4.
Good evening, ma'am.
Sorry.
Ma'am, I have doubt in week 3 graded assignment.
Okay. In week 3.
Graded assignment.
Okay. What is your doubt?
Ma'am, question number 13 and 15 and 16.
Give me a second. Let me bring that. 13 and then 15 and
16.
yeah, so what doubt do you have in these?
Ma'am, in this 13 question, this 2
Mm.
input AND gate is replaced with 2 input NOR gate.
Mm.
I do not understand the meaning, and then the represent A equal to MSB and C equal to SB.
Okay, I think we discussed this last class, the class before that. So it was for 12th question here, 13th. So in this diagram, you have to change the AND gate into a NOR gate and NOR gate to an AND gate. So your AND gate is here
Yeah.
and your AND gate is here and your NOR gate is here.
But in this question, any not this the 12 question is related in 13.
Sorry?
Ma'am, the 13 question is related in 12 question is
Mm.
not mentioned in our graded assignment.
Yes, yes, yes. I talked about this last class also, and I told that we'll rectify this.
Okay, ma'am, I do it.
Yeah, yeah. Someone bought this into notice last class also.
Yes, ma'am. I asked it last class. You
Yes,
told
yes,
that.
yes. So, and 15 and 16, what doubt do you have?
Ma'am, I do not solve these two question.
The hexadecimal representation?
Uh, yes, in negative term. Binary to hexadecimal for a negative.
Okay. So, so this is for decimal. They have given you decimal, right? Just give me 1 minute. I will bring it. So, to convert positive number decimal to hexadecimal, right?
Yes, ma'am.
So, how do you convert positive number?
Just divided by 16.
Okay. So, so now what we'll do is we will divide by 16. Okay. I think it will be easier if you convert to binary. Okay. So, minus 159, right? Base 10. So now can you tell me when you divide by 16 what is the output you're getting?
Yes, ma'am.
Hexadecimal, yeah. So when you divide it, what is the output? The result?
Ma'am, I do it in go to binary. I don't do.
Fine, you can tell me the binary value, no issues.
Ma'am, the positive value, then 1001 and four ones next.
001 4 ones.
1001, then four ones.
So you're getting this for your binary?
Yes, ma'am.
Okay. So, if you see, if you're representing this in 16-bit form, then how do you extend it if you're representing this in 16-bit form? Now, this is 8-bit form, no? If you're representing this in 16-bit, how will you extend it? You will add zeros,
Add
right?
70 and 11.
No, this is for
70 and 1.
positive
As
159.
a positive, then 80.
Okay. So now you got your positive 159. Now what we're trying to do is with using 2's complement, we're trying to solve. So what is the step for 2's complement? First we invert the bits and add 1, right?
Yes, ma'am.
So first we invert the bits. You will get 1 1 1 1 1 1 1 1 0 1 1 0 0 0 0 0 and then you add 1. So if you're getting 1 1 1 1 1 1 1 1 0 1 1 0 0 0 0 1. So now what is this in hexadecimal? So this is
1,
1 and this is
6,
and this is
F,
F.
and F.
So F. Okay.
Okay, ma'am.
Okay. So that and I think so you got an idea for 16th also, no? Minus 321 how to do it.
Yes, ma'am. I do it.
And why are we taking this zeros? As if you see in the option, all are like in the 4 bits, right? Like FF61 and all are 4 bits. So if it is like 4 characters in hexadecimal, then that will translate to 60. So we are just extending it here. Okay. So the same thing if you're doing 8. So if for 8, yeah, if you're getting let's say just 4 digits, something like 1111 1 1. If you're getting something like this, then you have to extend it till 60.
Yes, ma'am.
Okay. So yeah, any other doubt?
No, ma'am.
No? Okay. Okay, then continuing to practice assignment for week 4. So yeah. So the first question is yeah. So yeah, so for week 4 we saw what were the ideas we saw. We saw Boolean algebra, we saw properties for Boolean algebra. We also saw canonical form for sum of products and product of sum. So we'll be using basically these all. Mostly we'll be using the properties that we saw. So coming to this one, so so if you have A, C, and if you want to add a B term, then what we will do is we'll write B plus B dash. Why is it? So what is B plus B dash? B plus B dash is 1, right? So if B plus B dash is 1, so AC and 1 subsequently becomes AC, right? So just because of this, even if we add b plus b dash, it does not affect the equation because that is similar. Okay, so for this equation now, what we will do is we will do ac b plus b dash, and then for the next term there is no a, so we'll write a plus a dash. So then we have c dash b as it is. Okay. So now can you tell me with the distributive law what will come from this AC to this distributive law, AC this and AC this. So what will it be? A B C plus A B dash C, right? And now if we are taking C dash B to this A and then C dash B to this A dash. Now what will be the term?
It will be A C dash B plus A dash C dash B.
So A B C dash plus A dash B C dash. Okay. So when we are expanding it into terms with all characters, we are getting something like this. So if you come back here and look for the option, most of the option are either 4 or 3 digits. So for 4 or 3 terms. So for 4 or 3 terms, we have ABC, A B dash C, A B C dash, and A dash B C dash. So this option is similar to that. Okay. So any doubt in why we took B plus B dash? It is clear, right? We took B plus B dash because that will give us 1. So that one, when it is again, when we do AND operation with anything, it will give the particular term which is already there. So in that way, that will not change the question. It will be as it is. Okay, so moving on to the next question. So if you see the minimized form of the logical expression, this now here we are trying to minimize it. So here, if you take these two terms, so in these two terms, what are the common you're able to see?
B dash C dash B
B,
dash C dash B.
yes, you're able to see B dash, C dash, and D, and that will give you A dash plus A plus the remaining two terms, that is A, B, C dash, D dash plus A dash, B, C, D dash. So here, what is A dash plus A?
1.
1, correct. So when it is 1, then this term will become
B dash C dash D.
B dash C dash D plus, and then we will have these terms A, B, C dash, D dash plus A dash B, C, D dash. So if you see, are you able to find this term here? B dash, C dash, D. D, then you have A, B. So you have A, B, C dash, D dash, and then you have A dash, B, C, C, D dash. So it is option D. Okay. So moving on to third question, y is equal to 0. So now we are going to substitute y equal to 0 in this equation. So when y is 0, x plus 0, then you have x plus y dash is, what will be the value for y dash?
1.
1, correct. 1, and then you have x and y dash is again 1, and then you have plus x dash and whole dash. So now we are trying to simplify this. So what is x plus 0? What is the value that you
X.
x?
X.
X.
And x plus 1 will be?
1.
1.
1.
So now here and here again x and 1 will be
X.
X and 1 x.
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 And x plus x dash the whole bar. So x and 1 will be again
X.
x plus now x plus x bar will be
X bar into x.
x plus x bar.
X bar into x double bar.
Ma'am, 1.
Ah, yes, x plus x bar
Ah,
is equal to 1, right?
1 and then bar is 0.
0, yes. So 1 bar will be 0. So 0 plus x will be
X.
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 So you have a. Okay, now fourth question, select all the correct Boolean expression for the truth table given. So for the truth table here, we have to find. So if you remember, how did we find for one? How should we write? So for this one, how do we write the terms? Let's take
Sum of
SOP.
product.
SOP,
The
how
product
do
of
you
sum.
It will be A bar or dot or B or dot C bar.
Yeah, so you will get A bar, B, C bar. And this term will be
It will
A,
be
B.
A, B, C.
A, B, C. So now we write A bar, B, C bar plus A, B, C. Correct? Okay. Now what we will do is here. So what can you take common here? B. We can
And
take
B.
B common, right? Yeah. So B. If you take B common, we get A dash, C dash plus A, C. Okay. So now here what we will do is again we will write this using distributive law. Each term write this using distributive law. So how do we write this? B. So when you apply distributive law for each term, you will get A dash plus A. Then it will be A dash plus C. You will get C dash plus A. And then
C
C
dash
dash
plus C.
plus, yes. So now here, what is A dash plus A?
Ma'am, 1.
1. And C dash plus C will also become 1. So finally your result will be B AND operation with A dash plus C. Then you'll have C dash plus A. This is A dash plus C and C dash plus A. Okay. Okay. So yeah, so here if you see they have asked you for POS. They asked you for product of sums here. So, they have given you sum of products and they have asked you for product of sum. So what we will do is let's just take this down. Okay. Okay. So for this term, now they have given you x dash. They have given you x dash y z dash plus x y dash z dash plus x y z dash plus x y z. So now let's say I'm taking the table for x y z. So 0 0 0. Wait, I think it's on the top, right? We'll just paste it. Okay, so now if you take here, now what we will do is we will the SOP that we have, we will try to write it here. So the first one, so that is F. So that is a F, right? So the first one is X dash Y Z dash. So where will that come? So let's say this as M0, M1, M2, M3, 4, 5, 6, and 7. So now X dash Y Z dash. Which min term is that?
Ma'am, M2.
Yes, so it is M2. We have X dash Y Z dash. Same thing now, X Y dash Z dash will be X Y dash Z dash.
M4.
And now you have X Y Z dash.
M6.
Yes. And at last you have X Y Z. Seven, right? X Y Z.
Yes.
So now what happens if these all are ones? What will be the remaining terms?
0.
0. So these remaining terms will constitute for your max terms. Now write the max term for this. Max terms for this. So what is the max term for this?
X plus Y plus Z.
X plus Y plus Z. And now this?
X plus Y plus Z dash.
Z complement.
Yes. And this one?
X plus Y dash plus Z dash.
Okay. And this one?
X dash
X plus Y
Y
dash.
plus Z dash.
Plus Z. Okay. So now finally, how do you write max term? To write max term, which operator should you use in between these terms?
And
AND operator, right?
Yes, ma'am.
So you have X plus Y plus Z and X plus Y plus Z bar and X plus Y bar plus Z bar and X bar plus Y plus Z bar. So this is your term that you have now. So from your question, where is this term? X plus Y plus Z, X plus Y plus Z bar. So X plus Y plus Z, X plus Y plus Z bar. Okay, it's here. And X bar Y Z bar and X plus Y bar Z bar. So this one. Okay, so you understood if you're having sum of product, how to get product of sum from there, right? You can also cross verify it by, see, like if you have four terms here, four terms in your min term, then how many terms should you have in your max terms?
4.
4.
So we're having four here, right? And you also have to make sure that like, whichever term is not here, that will be in here. Okay. So this is for your fifth question. And okay, now moving on to sixth question. A function of Boolean variables xyz is expressed in. So here you have min terms format. So which one will be the sum of products for that function? So for zero, what is the min term? Do you need the this one 0, 2, 3, 5? Okay, so you can have this table here. So now we have to write minterm for 0, 2, 3, and 5. So now for 0, what is the minterm? X dash, Y dash, Z dash, right?
Yes, ma'am.
Okay. So then for 2, what is the minterm?
X bar, Y, Z bar.
X bar, Y, Z bar. And for 3,
X bar, Y, Z.
Y, Z. And for 5, X, Y bar, Z. Okay, so now we'll try to simplify this equation. So let's take now these two. Here x dash z dash is common, and you have y dash plus y, and I'm writing this as it is, x dash yz plus x y dash z. So here y dash plus y will be 1, and when you do x dash z dash dot 1, you will get x dash z dash plus x dash yz plus x y dash z. So here again, I'm taking x dash. Here I can take x dash common, right? So again, I'm taking x dash common, z dash plus yz plus x y dash z. So using distributive law, what will you get for this term?
Y plus Z dash.
Okay, one in okay. What did you tell?
Y plus Z dash.
Yes, okay, correct. Y plus z dash. So that, and then you will have x y dash z. So if I am taking this inside, then what will I get? X dash y plus x dash z dash plus x y dash z. Correct? So we'll see if we're having this term there. So yeah, we have x dash z dash, x dash y, and x y dash z. And now, two input gate is defined by, so they have given you the logic function. Now they are asking us to find for f of a bar b bar, comma f b comma b bar. Okay, now let's go step by step. So for this one, if a bar b bar, if a of b is equal to a b the whole bar, then what will be for f a bar b bar? It will be a bar dot b bar the whole bar, right? So here a is here, b is here, then a whole bar is given. So here the a is a bar, b is b bar, then we're having a whole bar. Is this clear? Okay, then what is the answer for this? When f of b comma b bar is there, then what is the answer for this?
One.
So you will get b bar dot b the whole bar. So this will be 0, 0 the whole bar will be 1. Okay. And now for this again, for this f, again we have to find one, the next result. So if you're having f, this entire thing, if I can substitute it, like simplify this, De Morgan's law, what will it be? A plus b, right?
Whole bar, I think.
Whole bar. So that whole bar will get divided into a bar the whole bar plus b
Oh,
bar.
yes, ma'am. Yes.
So this will be a plus b. Okay. So now again this term again if you're writing in this term, so you will get this a and this will be b the whole bar. So this will be a into b the whole bar. So now this term with AND operation with 1, what will you get? A plus b the whole bar, right? So now this is a simplified equation. Now from here, if they're asking you this one, which gate do you use? So which table is this?
NOR gate.
NOR
NOR
gate.
gate.
So you will use 2 input NOR gate. Okay. So now here we are using C as 0. So now if I'm giving C0 here, C0 here, then at this point what will be C at this point?
1.
Yes, C will be 1 here. So now at this point what will be the value? Which gate is this?
A plus B whole complement.
Correct. So you have A plus B the whole complement. And now this C is 0, right? So this C is 0. So now what will be the value here? If you're having A plus B the whole complement and you're doing OR of C is 0, what will be the result?
It will be A plus B whole complement.
Yes, A plus B the whole complement. Now what will be the result here?
A and B.
A, B. Now again here you have A plus B the whole complement plus A, B. Right? So let's say let's say we are trying to use De Morgan's law in this. So then what will it be?
A complement or B complement.
Complement dot B complement plus AB. Now if I am using, let's say, distributive law here. A complement plus A to A complement plus B, B complement plus A, B complement plus B. So this term and this term will become
1.
1, correct. So now at the end you have A complement plus B, B complement plus A. So this is what you have at this point. So at this point you have A complement plus B and then you have B complement plus A. So now this is NAND gate, right? So now you have 1. For this point you have 1 and this entire A plus B, B plus A, the whole bar. So now what is the term for this? So 1 and this, you will get these terms. So you will get A bar plus B, B bar plus A, the whole complement, right? So now if I am doing the De Morgan's law for this, what will it be? B the whole complement plus B bar plus A the whole complement. Now again I can do De Morgan's law for this, right? So what will that be? A complement, the whole complement will be A dot B bar plus, and what will this be? B dot
A complement.
Correct. So now if you see here, so here you have A complement B plus B complement. And then you also have, so okay, so now if you take this term, right? Where is this? Okay, the same term, this term. Now if you're trying to convert this into POS form, now this is in SOP form. If you're trying to convert this into POS form, so what do you get? We already have done it. That is how we bought. So if you see here, this is a POS form, right? So only from this, we came back to our SOP. So, sorry, not this. What was this? This was this term, right? So this was this term. So similarly, if you write POS form for this point also, so what will you get? Can any of you solve it? POS. So now we did the SOP. If you convert this into POS, what will you get? You don't have to do anything for just converting. Just do the distributive law here.
Option
And how
third.
you came to
I did not hear you.
Ma'am, option third.
Sorry? Do you have any doubts? Yes, so it is option third. Yes. How did we do? We just did distributive law. If you do distributive law, you will get A plus B, and you will have, and other terms will be A plus B. Next term will be A plus A dash, which will be 1. Then you have another term B dash plus B, which will be 1, and B dash plus A dash. This is your third term. So moving on to next question. So okay, so for in this question, they have given you three, they're telling there are three variables, and we are trying to find min term and max term. So we will find both min term and max term. So again, here, if you're getting this term, first what we will do is we will try to get this in terms of let's say SOP. That's easier for us. Okay, so first we will multiply this A within, or we can multiply this term with this term. Okay, so let's start with this. We will just remove the bigger terms. So if we are multiplying this term with this term, what will you get? You will get A, and then you will have B C dash plus B dash will be
0.
0. So we will leave that term out. Then we will write C dash, and C dash will be C dash plus C dash B dash. So again, if you see here, you can take C dash common. If you take C dash common, what will you get? Or you can take C dash common in all three. This is also C dash, right? So if you take C dash common in all three, what will you get? You will get B plus 1 plus B dash. So what will be the value for this term?
1.
1. So now finally I'm getting a C dash. Now if I have to introduce B to this term, how do we do it?
Multiply with B plus B dash.
Correct. Multiply plus B dash. Now I have A, B, C dash plus A, B dash, C dash. Okay, so now we got the complete term, three variable term. So now tell me, what are the min terms for this? What are the min term numbers for these two terms? So this one will be 1, 1, 0, and this one will be 1, 0, 0.
4 and 6.
Correct. This is 4, 6. So you will have minterm 4 and 6. And if minterm is 4 and 6, what will be the max term?
0, 1, 2, 3, 5, 7.
0, 1, 2, 3, 5,
7.
7. So you have M, 4, 6, and capital M, 0, 1, 2, 3, 5, and 7. Okay. Now moving on to next question. So they have given you a Boolean function that has to be implemented, and you're not going to assume any complements as given, but we are going to solve this using and or non gates only. So if we try to find out how many minimum NAND gates or AND gates are required. So the question is A dash plus B dash plus C dash. So we have Y as A dash plus B dash plus C dash. So for NAND gate, how do you get invert A for NAND gate? You want to just invert a single one. How do you get this? You just give A as 2 input here and you will get A dash. Okay. Now keeping this in mind, so what we will do is, so if I give A, B for my NAND gate, what will be the output? What will be the result at this point?
A dot B bar. A dot B the whole bar.
Correct. A dot be the whole bar. Now keep this in mind, and now if I use this single one, then if I two inputs are given as self here, then what will be the result here?
AB.
Correct. AB. Now you have another term, right? C. So you already have. So this term, if you use De Morgan's law here, right? What will you get? You will get A, B, C, the whole bar, right? Only when you get this will become A dash plus B dash plus C dash. Correct? So now C here, now I'm getting C here. And if I'm giving another AND gate, so what will be the result at this point?
A, B, C, the whole complement.
A, B, C, the whole complement. And what is A, B, C, the whole complement? It will be A dash plus B dash plus C dash, which is that we want, right? So how many gates did we use? 3, right? We use these. This is the one which we used. So we used 3 gates. So now next question is, if we use only NAND gates, then what is the minimum number of gates required? So we already used only NAND gates, right? We did not use any OR gates. So for the previous question, you can try it out and let me know if you have any doubts in the next class or later. You can try with NOR gate, and probably for NOR gate, you will get something around 4 gates. So you can try that also and let me know if you still have any doubts. So if you're using only NAND gates, again it is 3, because even in previous question we just used NAND gate. So now we have to select options, the minterm and max term for this expression. Okay. So now again, if we are having this term here, So let's say I'm trying to do the distributive law here. So it will be b a dash plus b dot b dash will be 0.
0.
Yeah, so we'll ignore it. And then we have b c plus c a dash plus c b dash plus c. So now for all these terms, if you see there is c, right? So if I have b a dash plus c in common and give b plus a dash plus b dash plus 1, what is the term for this one? It will be 1, right?
Yes, ma'am.
So here again you will get b a dash plus c. Now here, if I'm trying to introduce c here in this term, so how do we do it? B dash a c plus c dash. Plus similarly here also you can introduce it by a plus a dash b plus b dash. B plus b dash. So here again you have a dash b c plus a dash b c dash plus what will this term be? A b plus you have a b plus a b dash plus a dash b plus a dash b dash. Now if you have to end with c, then you will get abc plus a b dash c plus a dash bc, same term, right? So we are leaving it out, a dash bc plus again we have a dash b dash c. So now what are the min terms for these? So what is the min term for this first term?
0, 1,
Hmm?
0, 1, 1.
0 1 1 is
3.
3, correct. And then for the second term?
0, 1, 0. 2.
2, correct.
2,
And then the third term?
1,
7,
7. And this one?
5,
5. And final, the last one? 0 0 1 is?
1.
Great, yeah, 1. So finally you have 1 2 3 5 and 7. So you have 1 2 3 5 and 7. So if min terms are 1 2 3 5 7, what will be the max terms?
0, 4, 6.
0 4 6. Okay. So moving on to next question. So they have given you max terms. They have given you max terms and they're asking you to find inverse of that function. For this function, if they have given you max terms, they're asking you what is the inverse of the function. So the simple idea is for f, if the max term is 3 5 8 11, what will be the min term?
0, 1, 2, 4, 6, 7, 9, 10. And 12, 12, 13, 14,
50.
and 15.
So this will be a min term. So for a particular function, if you're getting f, if they're inverting the function, what happens is this min term for this function will become the max term, and this max term here will become the min term. The min term will become 3, 5, 8, 11. Okay, so now for f dash you have 3, 5, 8 and 11. So now can you tell me what is the term for 3, 5, 8 and 11?
A bar B C.
Okay, so this is for 4 terms. A, B, C, D. So for 3 you will get, for 3 it is 0, 0, 1, 1, and for 5 it is 0, 1, 0, 1, and for 8 it is 1, 0, 0, 0, and for 11 it is 1, 0, 1, 1. Okay, now let me know what are the terms. So for 3, what is it?
A B bar C D.
C, D. And for 5?
A bar B C bar D.
Correct. And for 8?
A B bar C bar D bar.
A, B bar, C bar, D bar. And for 11 it is A, B bar, C, D. So here if you see, so initially you have this B dash, yeah, see B dash CD, B dash CD, these are common. So you can write B dash CD, and A dash plus A will be 1. So now you have A dash plus B, C dash D plus A, B dash, C dash, D dash. So yeah. So you have pretty much the same answer, right? Yeah, B dash C D. Then okay, you can take C dash common here. So if you take C dash common here, and what will you get? You will get A dash B D plus A B dash D dash. So that is your answer. So mostly when you're solving, try to look at the options also so that you will know what kind of results you're looking for. Whether it is sum of products or product of sum, depending on that you have to do. So if you're, let's say you're trying to find if all the options here are in product of sum, then you have to do it using uh, pi m 0, 1, 2, 4, 6, 7, 9, 10 and so on. Okay. Okay, so final question. If x is equal to 1, so they have given you the value of x. So we are trying to find x plus z. Wait, let me. Okay, so for this one here, now x is equal to 1. So here I will substitute x as 1. So it will be 1 plus z y dash plus z dash plus x y dash 1, 2 and 3. And here again, what is x dash? 0, right? You have 0. plus z dash, and then for x you have 1 plus 1 plus y. This is equal to 1. So here in this entire equation, if you see, we have written 1 plus the entire term. So what happens to this entire term?
1.
Correct. So it is 1. So 1 and this entire operation. So you have, and 0 plus the other terms will be the remaining terms. So z dash and 1 plus y is 1. So again, x dash dot 1 will be x dash is equal to 1. So if z dash is equal to 1, then what will be z?
Zero.
Yes, so it will be 0. So if you see in the option, you can check if they're asking given z dash, it is not given, so they have given z is equal to 0. So it is 0. Okay. So yeah, so this is pretty much for the entire practice assignment of week 4. So apart from this, do you have any doubts in any weeks or week 4, any topic? Graded assignment deadline will be on 22nd. So submit both the submission on time. If you're having doubt at any point, you can just drop it in Google Space as well. You don't have to wait till the live sessions, okay? So no doubts. Okay. Then before we end the session,